So the power silicon interposer is really designed for handling the high voltages and currents in a power module. And we have, in Lotus, we have developed, I would say, methods or technologies that make it possible to create via structures in the substrate and also robust patterning on the surface of the substrate so that you can move power vertically and also laterally through and on the interposer.
Hey, it's Eamon with ipXchange, and we're here with another IP experience, this time with Hans from Lotus Microsystems. So they've got a very interesting technology, as always, but something a little bit different to what we talk about on ipXchange. So Hans, probably first thing to do is just say what you do at Lotus Microsystems and what is Lotus Microsystems all about? How did you get started?
Yeah, thanks, Simon. I'm Hans, and I'm the CEO of Lotus Microsystems. I joined in November last year, so I haven't been on board for that long, but it's a really a fun experience to be at Lotus. What is Lotus all about? So the company was founded in 2020 by three founders, Yasser Noor, Wael Etan, and Ahmed Ammar. And they are all three PhDs from the Technical University of Denmark here in Copenhagen, where we have our main office. And during their PhD work at the university, they work with power conversion, with integrated power supplies, semiconductor process technology, and packaging technology. And so the idea of the power silicon interposer really came out of that work during their PhD work there.
Nice. So power silicon interposer, that's probably a term that not many people have heard of. So can you please briefly explain what this is and what makes it important, I guess, in power applications?
Yeah, of course. Yeah, so silicon interposers have been around for a number of years, and they are being used for connecting multiple chips placed on the same substrate. But these conventional interposers, silicon interposers, are really designed only for signaling. So, to carry logic level signals between, for example, a processor chip and a memory module. But when you look at an integrated power module, you also need a substrate there to hold the different components that go into the module. But in this case, the interconnections between those components have to handle high voltages and currents. So this is really where the idea for the power silicon interposer came from, and eventually Lotus was founded in order to mature this technology and take it to market.
Okay, so I guess the silicon interposer itself is being used to help place other components within a modular package. So would it be correct to say that Lotus Microsystems is a packaging company, or is that an oversimplification?
Well, we are a packaging company in the sense that we work with advanced packaging technology, but I think I would rather call us a power solutions company.
Okay.
So we do design our own power converter chips and of course the power silicon interposers, and then we design packages that house these components and eventually form power delivery modules.
Okay. So in terms of performance for power electronics, what is so important about or groundbreaking about the silicon interposer as opposed to what's currently out there?
Yeah. So the power silicon interposer is really designed for handling the high voltages and currents in a power module. And we have, in Lotus, we have developed, I would say, methods or technologies that make it possible to create via structures in the substrate and also robust patterning on the surface of the substrate, so that you can move power vertically and also laterally through and on the interposer. And then you might ask, okay, so why use silicon in the first place? And that really has to do with some of the essential properties of silicon. So first of all, it has excellent thermal conductivity. So it's actually more than 150 times better in conducting heat if you compare it to FR4 circuit board materials. And yeah, just to elaborate a little bit more on that. So and the other thing that's good about silicon is, of course, that we have today very precise photolithography techniques that have been developed over decades, and this really allows for very compact designs. And as a third part, a third benefit, you have when you use silicon as an interposer or a substrate, then you don't have any problems with when you place another silicon chip on it. You have the same thermal expansion coefficient. So that means that mechanical stress is really minimized with silicon interposer.
Okay. So, I mean, it sounds like you're talking about very compact devices, but I had a look through your website and we're talking about 1,000 amps running through a single package. So what kind of applications are we talking about that you'd use Lotus Microsystems module in?
Yeah, so we do develop solutions for different applications, but our overall focus today is to really create solutions for what I would call the computing space or market and data center market. And so
okay.
So looking at looking at that, that includes creating the power supply solution that can power the big GPU or CPU processors in those installations, and that's definitely something that requires today it requires thousands of amps of current. But we also, so when you look at this space, we also create solutions that you could say can go into the infrastructure of a data center. For example, for the optical transceivers that you could say are the communication backbone in a data center. So that's another you could say product that we aim at this space, but obviously at lower power levels than for the main GPUs and CPUs. So that's another product type or category for us in this space. And then we have something that we call thermal bridges, thermal bridge components, and these are you could say small interposers, that can be. For example, it can be placed right next to a CPU or another hot area in a circuit design to locally remove heat away from the heat source and move it into a cooler area on the PCB or in the PCB plane, basically. So there are different, you could say, applications of what we do with where we can apply the interposer.
Okay, so in that case, I guess you're talking about. You have your power modules which use the interposer technology, but you also sell interposer solutions for removing heat from larger components, so you can get the benefits of that technology without necessarily using Lotus Microsystems power solutions. Is that correct? Well,
I mean, so our interposers can definitely be combined with third-party converters. As I said, we do develop our own converter chips here. So obviously, we prefer to design the whole solution, but there's no issue in you could say combining, like let's say a third-party DC-DC converter with our interposer technology.
Okay.
That can definitely easily be done. Yeah, for sure.
Nice. And so obviously you've just touched upon GPUs and data center applications. So we're always talking in the office about AI and trends in power technology. So I'd like to ask, what kind of trends do you see in power technology to support AI? And I guess you're already supporting that, but what are your general insights in what's happening at the moment?
So the area of power electronics is, of course, that's a big topic and very diverse topic. But if we look at the computing space that I mentioned before, it's I think it's well known that the bar is constantly being raised when it comes to power delivery, power efficiency, and thermal management and cooling. I think you just have to take a quick look at that market and to quickly understand that this is these are major challenges in the AI space and in the compute space in general, and in data centers. And so and why is that? So one of the reasons is that obviously we see continued shrinking of process technology when it comes to the advanced process nodes that are used for GPU and CPU processors. So obviously they are used in these in the AI and data center applications. You have the absolute most advanced process nodes coming into play there. And so what does that mean for power? Well, it means, first of all, it means more transistors per square millimeter, basically. So more power per square millimeter is required. But it also means that when you work with smaller and smaller transistors, smaller and smaller process nodes, that the supply voltage goes down for the logic on these chips here. And that means if you increase the power and you lower the supply voltage, then the current goes up quite dramatically, actually. So suddenly you are in this situation where we are now, basically where you need thousands of amps running through thin traces and creating an immense power dissipation. Simply just running thousands of amps through circuit board traces will create an immense heat dissipation. So that's really I think it all boils down to one term here, which is power density, right? Everybody in this space is talking about power density. So how much power, how much current can you deliver per square millimeter, basically. That is the challenge that companies like us are being faced with now. So I think that is an absolutely key trend in the market that we are shooting for right now.
Cool. I guess just to clarify, say when it comes to Lotus Microsystems power devices, what kind of modules do you offer? And in that kind of data center application, how many GPUs would a single module be responsible for?
Yeah, so in Lotus we develop actually different types of products, in the sense that we do have some what you can call catalog products, meaning that those are designed for general use. They are obviously designed to fit certain applications, but anybody can acquire them and use them for their application if it fits into that specific application. So those are our catalog products. When we look at the data center or AI or computing space, we are that is really a more custom design case, where we cannot design I would say a solution that would fit several of the GPU or CPU providers, because simply there's no standard industry standard for how to create a power solution for these applications. So in that case, we have to work very closely with the processor developers to understand their requirements and therefore and thereby to create the right solution for them in each individual case. So I can really it's really not possible for me to say one module from us can power this many GPUs. That really depends on the application and the vendor, I would say. Yeah.
Okay, that's fair. And I suppose kind of a follow-on to that question is, obviously you've developed the silicon power interposer, power silicon interposer, sorry. But in terms of other IP that you use to make your chips, do you use IP from other vendors so that you can make modules that are kind of based on other designs, but you get the full benefit of your packaging?
We do not use third-party IP as such. No, I mean I would say our main IP is within the interposer, the power interposer area. This is you would say the unique element that we bring into the power solutions for the applications that we target. However, we are also developing, as I said, converter chips to be combined with the power interposer, and those and they're definitely you could say there's IP there that we will protect as well, but
Okay.
this will be internally developed. That's how we will go about that. Yeah.
Okay, cool. Yeah, I just wanted to clarify. So I think we've covered quite a lot in this one, and we do have another chat planned with you to really go deep into the technology. So if anyone's watching this and wants to learn more from how can you get in touch, how can you start using this technology, what's the best way to go forward?
Well, I mean, we can definitely be contacted through our website. There's a contact form there, and also an email address. So you're definitely welcome to reach out there. We're also present on LinkedIn, so that's another online channel that can be used. And then I would say we definitely we also participate in various conferences and trade shows that are within our industry. So we typically are available either exhibiting or just being present at the most relevant power conferences and trade shows. So we're always happy to meet engineers there and have a chat about what's moving, what's going on in the world of power and power delivery solutions. Yeah.
Cool. Just for our audience's benefit, what are some examples of those shows, just so that if they know it's on their calendar, they can just pencil it in and see if they can get a meeting?
Yeah, so most recently we were at PCIM
Okay,
in
nice.
Nuremberg in June. We were also at CES in Las Vegas in January. So yeah, those are different types of shows, obviously,
Mm.
but we at PCM we'll definitely be there again next year, and most likely also at CES. And from time to time we announce on LinkedIn that we will be present at this and that shows. So I think just keep an
Okay,
eye open for and you'll be able to meet up with us at those events.
excellent. And just one question that I do want to ask, just out of clarification, I probably should have asked it earlier, but is this technology ready to go, or is it in development? Do you have some timelines?
Yeah, so we are releasing some products very soon, actually,
Okay.
based on our technology. So it will be available quite soon. So I just keep an eye open for that. We'll make it available, or we'll announce it on our webpage, of course.
Cool.
But we are, I would say, in terms of the interposer technology itself, we have developed and matured it over the past years, but there's definitely more to do. So we continue our R&D work in this technology. It's still you could say it's still a young technology. So there's
Mm.
definitely a lot that we can still do and are still doing. So yeah, we continue to improve the technology so we can make better solutions down the road.
Cool. And I know that we talked a lot about kind of computing applications, but are there any other applications that you'd really like to hear from engineers coming from to test this technology?
I mean, our technology can basically be used in, I would say, in any application where you would have challenges with power delivery and thermal management. So this
Okay.
can range from, as I said, the computing space, but also in let's say in telecom applications, IoT applications, some medical applications as well.
Okay.
It's really not a matter so much about the application, but more about are you facing certain challenges regarding power delivery and thermal management, then I think you should be looking in our direction, basically.
Cool, excellent. Well, I think that's a perfect way to end. So thank you so much, Hans, for joining me today. And I will also be talking, I guess, am I talking to you tomorrow, or am I talking to another member of the team?
You are talking to another member of the team who's able to go more into details with the technology.
Cool. Well, to everyone out there, you can look forward to that discussion as well. It probably won't be 2 days in a row in the actual schedule, but I'm looking forward to it and learning more about Lotus Microsystems. So again, thank you so much, Hans, for joining me today for this introduction. And anyone looking at power electronics where you've got problems with heat management in high power density situations, I think Lotus Microsystems are the company to look at.
Thanks for having me.
Hey, where my engineers at?